screencast thing. Okay, starting off, yes, we're going to be doing logarithms. They're not big, scary things. Logarithms are just a special way to describe exponents. It's a different kind of exponent. So anything that's written with a logarithm can be changed to an exponential form. Okay, so we say this is log base b. So the little base becomes a big base. The logarithm is equal to the exponent, so the y goes over here, and then x goes over here. Now I want to make one quick note, and that is the domain has to be positive numbers. Well, you can't take a logarithm of a negative number. You'd get an error when you plug into your calculator. Fractions are okay. You're allowed to have fractions. Yeah. Okay, so here's what we're going to do. We're going to just first practice writing from logarithmic to exponential form, and then we'll go the other way. All right, so here's what happens. Log base 3 of 9 equals 2. So the little 3, so little base becomes big base. So this is a base. This goes here. This, what's on the other side, becomes the exponent equals 9.
Oh.
Okay?
And that's the answer.
And that's it. That's all we want to write.
Okay.
Okay.
Oh, okay.
All right. So little 10 becomes big 10. So the negative 2 equals, we should be able to check, confirm,
Yeah.
are these statements true?
They are.
Yeah.
But this is really easy. Oh my god.
Okay.
But that's really
Next
good.
one, 3 to the 6 equals,
729.
okay.
Whoa.
This is so easy.
Oh.
my god.
What?
I forgot to write in here. The answer to the logarithm is always an exponent. Logarithms are exponents. That's all they are.
This is really, it's really easy lesson. Well, we say that now, but.
You say that now. Trust me.
I just hope we don't jinx it.
Okay, now let's take something in exponential form and rewrite it in logarithmic form. So we're going to have log base 5 of
125 equals 2.
125 equals 3. That's all you have to write. Log base 27 of 3 equals 1/3. And last, log base 6 of 1 over 216 equals -3. So anything that's in an exponential function can be rewritten as a logarithmic, and anything logarithmic can be rewritten in exponential form. Okay, how does that help us? Well, let's say I want you to evaluate these, and we're going to evaluate them without a calculator. So it says log base 2 of 8. Let's make that equal to x. Can we rewrite this in exponential form now?
Well,
It would be 2 to the x equals 8. So
Oh.
so what does x have to be? What
3.
power of 2 will give us 8? 3. So when I look at this, now you can start doing these in your head too. So what I'm basically saying, when it says log base 2 of 8, I'm saying 2 to what power gives us 8? 25 to what power will give us 5? 4 to what power gives us 64? So remember, when we're answering logarithms, we're saying what does the exponent have to be? So let's look at the next one. 25 to what power? This wouldn't have to be a square root of 25? So that would be a 1/2 power. Because it's a square root. Okay. 4 to what power will give us 64.
3.
3.
Next page won't be 3. 6 will probably be
6 to what power?
-2.
-2. Good. This is why we have these two lessons combined, because this is like, okay.
So where did we learn? What chapter was it that we learned power or like?
Oh, good question. I have to look back. Okay. All right. 1/9 to the x.
Yes, yes, fine.
Right? 1/9 to the x gives us 81, 2. And last, we have 10 to what power gives us,
100,000, and that's 5.
how many zeros do we have?
5.
5.
Wait.
5. It's 100,000.
Adding 4 zeros.
No, but it's 10 to what power? 1, 2, 3, 4, 5. It's just
I think you're right.
count the zeros.
It's 5.
It is 5.
Yeah. Right? Because 10 squared would be 100, 10 to the third would be 1,000. Good? Okay. Okay, we're actually not going to worry about this.
Oh.
I'm sure you're very upset about it.
Oh yeah, we're so sad.
So-
No.
I'll just talk about, so one of the things people ask about is, well, okay,
Not
there's
the Richter scale.
There's a lot of reasons we actually use logarithms, and they are used in something like the Richter scale, like how we measure magnitude of earthquakes actually uses logarithms. Okay,
Well, wait. Oh. Are we doing 7.42?
yep,
Oh, I was not aware of that.
we're doing 7.4 as
Yeah,
well.
now it's gonna be a little harder, isn't it?
Oh, it's a page.
Oh, we're going on. Oh, we have to solve a quick one day. It's 1 page. Oh, so?
Look, guys,
serious?
it's
Okay.
1 page. Look, so far, how was 7.3? Easy.
Extremely
Okay.
easy.
So let's combine what we did in the last lesson.
Wait, this is 1 page.
It's 1 page. Now we're going to solve logarithmic equations using the definition. Okay. How can we rewrite this? So this time I'm not solving for what the logarithm's equal to. Now the x is going to be somewhere else. But we could still rewrite it. That would be 8 to the 4/3 power equals x. Okay, with just a quick reminder, when we have something to, like if it's m over n, one of these is a power and the other one is the root. Do you remember which one?
The bottom is the root. Or the power.
The bottom is the root.
Yeah.
And then the top number is the power. Okay, so if I have 8 to the 4/3, I want to take the cube root of 8 and then raise that to the 4th power. So what's the cube root of 8?
2.
2. What's 2 to the 4th?
16.
16.
Oh, wow.
So x equals 16. All right, next one. We have 16 to the
3 over 2.
equals x. Okay, so the bottom number is the root, the top number is the power. So we have square root of 16,
64. Yeah.
and then we want to cube it.
Yeah,
So
64.
64. Okay.
Oh, this should be fun.
Wow.
Did you just get
Now x. to the
I took the square root of 16 as 4
Equals 30.
to the 3rd power, so that's 64.
God.
Okay, x to the 5/2 equals 32. Did we get that first step?
Yes.
Okay, now this one's a little different. How can I get rid of a 5/2 power? I'm going to raise each side to the 2/5 power. Why would I want to multiply reciprocals Because what do I want the power of x to be? 1. So these basically will cancel. You're raising each side to the reciprocal. Okay, so now we're just going to do the same thing, right? 5th root of 32. Okay.
And then squared, so it's just 4.
Yeah, 5th root of 32 is 2.
And then
Squared is 4. Okay, one more of these. 8 to the x equals 1/2. Okay, now this, we can think of what we did in the last lesson. Can we make these have the same base?
Yeah.
You can make them both have a base of 2.
16 over
So this would be 2 to the 3x. Are you okay if I just write it that way? And this one would be 2 to the -1, right? We have a reciprocal. Okay, so this is kind of what we did yesterday. What could we do?
1/3.
It's just
Negative 1/3.
3x equals -1. So x is -1/3. Okay, last thing, and we'll actually have time for homework today. Yeah. Okay, the property of logarithms basically says if they're equal, if the bases are equal, then we can set what we're taking the log of equal to each other. Just a quick reminder, we always have to make sure that whatever we solve for, like when we solve for x, we have to make sure that it's always greater than 0. Good?
I don't understand this. I think if I see
Okay,
it, I'll
listen,
understand it.
here's basically the idea. You see how there's a log base 4 on both sides?
Yeah.
They get canceled.
Yeah.
Oh.
Yes. So then it's just x squared equals.
Yeah, so
And you just solve.
based on the fact that you have a log base 4 on both sides, we just cancel it. Can we move everything to one side? Yes. So plus 6x plus 8 equals 0. Does that factor? Yeah, it's going to be,
4 and 2.
oops, x plus 4. Sorry, am I going too fast? A little fast?
Oh, yeah.
-4, -2.
Now, what I want to do is I want to make sure, what happens if I try to plug in -4 here and here? Well, if I plug it in on the left side, that's going to give me log base 4 of positive 16, right, when I square it. What happens when I plug it in here? Same thing. So remember how I said you can never have a negative? That just means when I plug it back in, I can't have a negative number. But if I plug it back in and I get a positive, then we're okay. So do both of these values work when I plug them back in? Which one doesn't? They both work, because if I plug in -2, I'll get positive 4 here.
Oh.
If I plug in -2 here, that'll give me 12 minus 8, which gives me 4. So they both work.
Okay.
Okay. How about the next one? Right, they're going to cancel. We have log base 5 on both sides. Let's get everything on one side. Also factors. What's this one factor?
-2, no.
Yeah, you were right. Oh no, you're backwards. You said, or you did say -5 and m plus 2. So x equals 5 and -2.
Wait, but isn't it?
Okay, one of these won't work.
-2 won't work.
The -2 doesn't work because if I plug it back in, I would have a negative number. So it's kind of like, remember when you would solve for x in geometry and it was okay if you got a negative value, but if you plugged it back in and you got a negative angle measure? Yeah, it's the same idea with logarithms. Okay. Last one, solve the equation for m. Okay, so here's what we're going to do. We're going to treat this kind of like just a regular algebra problem. I'm going to add 15 to both sides. So I have n plus 15 equals 7 log base 4 of m. So my goal is to isolate m. Okay, divide both sides by 7. So I'll have n plus 15 over 7
What about the log 4?
equals log base 4 of m. This is going to be the last.
You can't divide by log base 4.
I can't divide by log base 4, but can I rewrite this in exponential form?
Probably. Yeah.
Okay, what number? What's our
4.
base?
4.
Good. So
4
Little-
to the
4,
power of
15
m.
plus n over 7.
4 to the n plus 15 over 7 equals m. And there's nothing we could do to simplify that.
That's it.
That's it?
Oh, it just doesn't. Oh, okay, yeah. I thought so, yeah.
Okay.
Therefore, I need to bring the, okay.
Yeah, there's nothing you can do because of the other variable.
Yeah, makes sense.
I see.
Okay, let's see. Look how much time that takes
I
us.
said it twice. That's
And you were worried. Okay, this is number 23.
What?
You have 2 lessons or one?
all the time.
I mean, 2.
It's 2 homework pages, but do you remember how short and easy the ones were at the beginning? You'll see when I open up the book.
No, it gets it. No, he used to say to my mom when she was a child. Okay,